Okay, this was your homework over the Thanksgiving break. This first question says the volume of a cylinder is 200 feet cubed. If the diameter of the cylinder is 8 feet, find the height of the cylinder rounded to the nearest thousandth of a foot. So what I did was I made a little version of the formula sheet. And real quick here, we see that the volume of a cylinder is big B times H, where B is the area of the base. Tomorrow I'm going to give you a blank formula sheet, meaning it's just going to have the type things that you would get on the Regents. It's not going to have a handwriting on it. So at any rate, the volume of a cylinder is big B times H. And because a cylinder has a circular base, big B gets replaced with pi r squared. And now they told us the volume was 200. Notice there is no pi there. That's important. Equals pi times, they told us the diameter is 8, which means the radius is 4, times the height. 4 squared is 16, so we have 200 is 16 pi h. And now we want to find the height to the nearest thousand, so we're going to divide by 16 pi. And h is equal to a number that we're going to get from our calculator. Important, really, really important. If you're using one of the old school 83s, you need to really understand how to do this. 200 divided by parentheses 16 pi, okay? And that equals 3.978 blah, blah, blah. If we want to round that to the nearest thousandth, I would want to round to the number that's in the eighths, this first eighths place. So I look to the next door neighbor, and the next door neighbor is bigger than 5, so this would round to 3.979. And since it's the height, the units would be in feet. Okay? Important to put parentheses around the 16 pi. Absolutely critical. Otherwise, you're going to get the wrong answer. Okay, so number 2 says a rectangular pyramid has a height of 18 inches. The rectangular base has a length of 5 and a width of 4. Find the volume of the pyramid. So if we go back to our formula sheet, here's our formula sheet. We're talking about the volume of a pyramid. So the volume of a pyramid formula is 1/3 big B times H. Okay? It's a rectangular pyramid. So the base is a rectangle, and the area of a base, the area of a rectangle is length times width. So big B is being replaced with length times width. So now we have volume is 1/3 times, they told us the base has a length of 5 and a width of 4. So that's 5 times 4 times the height of the pyramid, which was 18. A lot of you forgot the 1/3. What you kind of have to remember here is, first of all, you have the formula sheet. It says the 1/3 on it. So that's one big thing. The second big thing is, I kind of said this to 9th period today. I said, a pyramid is kind of skinny. It kind of looks like it went on a diet. So it's 1/3 of what a prism looks like, or 1/3 of what a cylinder is. So V equals 1/3 times 5 times 4 times 18 turns out to be 120. This is volume, so the units would be inches cubed. There's your final answer. All right, number 3. Another really important question where you really need to understand how to use your formula sheet. So I want to copy over the formula sheet, and here it is. Okay, the lateral area of a cone is 600 pi square centimeters. Once I see lateral area of a cone, those words, I need to look at my formula sheet and go, okay, where's lateral area of a cone? Lateral area of a cone is right here. L equals pi r times script L. So I'm going to write that right on the formula sheet. Right on my paper like this. Then it says if the diameter of the cone is 48 centimeters, find the volume of the cone. So I need the volume formula for a cone. Volume of a cone is 1/3 big B times H. All right. I'm going to get rid of the formula sheet because I don't need it anymore. I wrote down all the formulas that we needed. Okay. The other thing that you need to do with a cone is you absolutely positively need to draw the cone. So a picture of a cone on the side of your paper, and you draw that magic right triangle in the middle. Okay? So let's work with what they gave us first. They said the lateral area of a cone was 600 pi. So I'm going to work with the lateral area formula first. So we have 600 pi equals pi times the radius. Well, the diameter is 48. The radius is half of that, which is 24, and I can put that on the diagram, times script L. And remember, script L stands for the slant height. That is on the formula sheet. It says that. Okay? We customarily put the 24 in front of the pi. And now this equation, if we solved it for the letter that's there, that would be the slant height. So we're going to do that. We're going to divide by 24 pi on both sides. And so now L is equal to 600 pi divided by 24 pi, and this turns out to be 25. So script L is 25. Okay. And notice that goes on the slanty part of the cone because it is the slant height. Now, they asked us to find the volume in terms of pi. The volume formula is 1/3 big B times h. But since we have a circular base, big B gets replaced with pi r squared. So now we can fill in what we know. We have 1/3 pi times the radius, which is 24 squared, times the height. Now, h is the regular height, okay? Not the slanty slant height. So right now, we need to find out what this is. So we're going to take a little side trip and find out what the h is using the Pythagorean theorem. So to find out what h is, we need to understand that here's h, and the Pythagorean theorem applies here because we have a right triangle inside the cone. So I want to write h squared plus 24 squared equals 25 squared. So h squared plus 24 squared is 576 equals 625. Subtracting 576 from both sides, we get h squared is 49. Taking the square root on both sides, h is 7. So the height of the actual regular height of the cone, which is what the volume formula asks you to fill in, is a 7. And then you can multiply all this out. 24 squared is 576 times 7 times 1/3. So I will do that on the calculator. We would get 24 squared times 7 times 1/3. This is one way to do it. And you get 1,344. And they asked us for the answer in terms of pi, so we can keep the pi. So the final answer is 1,344 pi. Units would be centimeters cubed, or cubic centimeters. Final answer. This question is critical. You got to be able to know how to do it. It's multi-step. And it's a good question to ask because it really, if you really understand this question, you really understand everything about the volume and lateral area of a cone. All right, number 4. It says the volume of a diamond in the shape of a pentagonal pyramid is 132 cubic millimeters. If the height of the diamond is 4 millimeters, find the area of the base of the diamond. Again, we really have to go back and look at our formula sheet. So I'm just going to go back and steal the formula sheet for a minute here. Here's the formula sheet. And right now, we need from it the volume of a pyramid. So some of you are having trouble reading if we put in any words here besides the shape, you're having trouble reading. It says the volume of a pentagonal pyramid. So the volume of any pyramid is 1/3 times big B times h. Now I want to draw your attention to something. It says specifically on the formula sheet, whoopsie. It says specifically on the formula sheet that big B is the area of the base. Okay? If you notice, that's what they want us to find. They want us to find the area of the base. So they want us to find out what big B is. So we know the volume is 132 equals 1/3 times what big B is times the height, which is 4. So some of you did the following. You did 1/3 times 4, which would be appropriate. 1/3. Actually, let me put that in parentheses. It's a fraction. 1/3 times 4. And that gives you 1.3 repeating. So we know that this guy times this guy is 1.3 repeating times big B. And now we want to solve for big B. That's the area of the base. So we can divide by 1.3 repeating. If you're on your calculator to do this division, you can do 132 divided by 1.33333 and just fill in as many threes as you can so that it fills up the line, and big B is 99. Now the units are important. Big B is the area of the base. Areas are always measured in square units. So if your units are millimeters, which is what they gave us, the area is in millimeters squared. Last but not least, number 5. It says a Toblerone chocolate container is pictured below. Toblerone needs the container to hold 72 cubic inches of chocolate. The height of the triangular face is 4 inches and the base is 3 inches. How long should Toblerone make the container so that it will hold 72 cubic inches of chocolate? All right, filling up space, that's volume. So we definitely need the volume formula for a prism. This is what this is. This is a triangular prism. Okay, if you've ever seen Toblerone candy, it comes in this package. Whoopsie, that's terrible. Okay, it is a triangular prism now. Okay, you have one triangular face, another triangular face, and they connect up together. Okay, so we have to go back here for a moment and grab our formula sheet. We are trying to find the formula for the volume of a prism. Whoopsie, didn't mean to do that either. Delete that. Paste this. Now, notice it does not say prism anywhere on the formula sheet. However, what we did in class was we realized that a prism and a cylinder are the same thing in terms of their formula for the volume, because prisms and cylinders grow up the same way. They grow up to become them because they have a height. So the volume formula is big B times H. Now, this is a triangular prism. Big B is a triangle, or the base rather is a triangle. So big B is the base times the height of that triangle divided by 2. Times, I want to put this H in blue, it's the height of the prism. Okay? It's coming from the prism, which actually in this case is here. That's the height of the prism, not the height of the base of the triangle. So now let's see what else they gave us. They told us the container needs to hold 72 cubic inches of chocolate. So the big V is 72 equals, the little b is coming from the base of the triangular face, which is 3 inches. So 3 times that's big B, times the height of the rectangular face is 4. Divide that by 2 times the height of the prism. So 3 times 4 is 12, divided by 2 is 6. So we get 72 equals 6 times the height of the prism. And the height of the prism is how long we want to make the Toblerone package. So if we divide by 6 here, we get H is 12. And this is measured in inches because it's a height. And 12 inches makes sense for this because it's a Toblerone candy bar. It's about 1 foot long. It wouldn't make sense if this was like 60 inches. That would be like 5 feet. So you had to make sense of the answer. All right. We did these 3 in class. We did number 1 in class. Number 2, I did it with 9th period, but I didn't end up doing it with 4th period. So number 2 says, what is the effect on the volume of a cylinder if the radius is doubled while the height is halved? Well, so what I said, a strategy we can do with this is to pick a cylinder and pick nice numbers for the height and the radius, and then do what the problem says and come up with an example. So it says, well, at first we have to pick numbers for the volume, for the radius and the height. Because remember, the volume of a cylinder is big B times H, which is pi r squared H because we have a circular base. So I want to pick numbers that are easy to double and easy to halve. So I'll make the radius say 4 and the height say 8. Okay? Now, I want to double the radius and halve the height. So this new cylinder would look like something like this. It would be fat and squatty. So double the radius becomes 8. Halve the height becomes 4. Okay? And now we want to calculate the volume of each of these sorry, of each of these cylinders. So let's see. The first cylinder, the volume would be pi times 4 squared times 8. 4 squared is 16. 16 times 8 is, sorry, 16 times 8 is 128. So we get 128 pi for the first cylinder. Then the next cylinder, plug in its numbers. I don't know why I'm putting a half here. So that's silly. Get rid of that. I'm sorry about that. That shouldn't be there. So we get pi times the radius is 8 squared times the height, which is 4. So we get 8 squared, which is 64 times 4, which is 256 pi. So even though we doubled r and halved h, they didn't actually just cancel out. What still happened is, if you notice, 128 times 2 is 256. So the volume actually gets multiplied by 2. So the right answer here is the volume is doubled. If you think about why for a minute, if you notice, the radius gets squared. So whatever happened to the radius gets whatever happens to it is amplified. So what I mean by that is, when you double r, what you're really doing is you're multiplying r by 2 twice because it appears twice. So what happens is you're actually quadrupling. You have kind of a quadrupling effect, an effect of multiplying by 4 there. All right. Number 3, it says at the edge of each edge of a cube is doubled. What is the effect on the volume of the cube? So a cube is a rectangular prism, except all the edges are the same length. So I'm going to pick an edge of 3 for a moment. Okay. Then it wants me to double the edges. So here's my new my new cube with doubled edges. So each edge becomes 6. The volume is just length times width times height. So volume is 3 times 3 times 3, which is 27. Volume over here is still length times width times height, which is 6 times 6 times 6, which is 216. So now if I want to figure out what number I need to multiply to get here, I can do 216 divided by 27, which happens to be 8. So if I multiply by 8, I will get from the 27 to the 216. So the volume would be 8 times greater. All right, number 4 says, the accompanying diagram shows a right circular cylinder inscribed in a cube. If the length of the edge of the cube is 20, then what is the volume of the cylinder? So again, volume of a cylinder is big B times H. Big B gets replaced with pi r squared since we're working with a circular base. And what we need to figure out are the radius and the height of the cylinder. So if you notice, since the cube is 20, okay, if I took this length, okay, and I decided I was going to, like, for example, clone this, okay, this length and the height of the cylinder are actually identical. So we now know that the height of the cylinder is 20. Also, since this is a cube, all the edges are 20. So for example, this edge is 20. Now if we looked at this for a moment, half of 20 is 10. And if you notice, that 10 is precisely the radius of the cylinder. So the radius of the cylinder is 10. So now we can get the volume in terms of pi. 10 squared is 100 times 20. 100 times 20 is 2,000. Important units are important. This the lengths were measured in centimeters, so the volume is in centimeters cubed. Okay. All right, number 5 says, what is the volume of the triangular prism below? The volume formula for a prism is big B times H. Since this is a triangular prism, the area for a triangle is base times height over 2. That's what your big B gets replaced with. Times the red H is coming from the dimension that makes this a cylinder, a prism, which is the kind of the depth or the height of the cylinder, which is 7. So now we can just plug in all our numbers. The base of the triangular face is 6. The height is 3. Divide that by 2 times the 7. 6 times 3 is 18. Divided by 2 is 9. Times 7. The volume is 63. And it would be meters cubed. Next question. A lot of people are confused about this because I'm not quite sure if you understand what's going on. This whole thing is about, like, if you ever open up a box of cereal, and you open it up and you feel like you got gypped because they sold you half air. This is basically what's happening. So a bulk cereal producer wants to fill a jumbo-sized box with this brand of rice flakes. They decide to fill the box 1 inch from the top instead of filling it completely. So they will fill up not 12 inches, but 11 inches. So this blue region here will be filled with cereal. So fill with cereal. And then this top part, which I'll outline in red, will be complete empty airspace. It'll just be air. Okay? It says, how many cubic inches of rice flakes will the producer save by not filling the box to the top? So the red part here, this red part here, is what he's saving. He's saving that amount of cereal because normally if he was being honest and filled that all the way to the top, he would have to fill that, he would have cereal in that space. So if you notice, 8 inches here, okay? The red is still 3 inches here. And now since we saved 1 inch of space, the height is 1. So if I took the volume of the space I'm saving, which is the length times the width times the height, that would be 8 times 3 times 1, which is 24 inches cubed. The other way you can do it is to get the volume of the whole box and get the volume of the blue part and subtract them. So people did it that way also. All right, number 7 says fruit juice comes in 2 types of containers. The first is a rectangular prism that is 9 inches tall and has a rectangular base that measures 2 by 3. So I'm going to draw that. Sorry. Let me draw that better. It's kind of a tall juice box, like a Juicy Juice or a Sips box. All right. It says it has 9 inches tall and a rectangular base that measures 2 by 3. So all right. So let's leave it at that. The second container is a cylinder. So second container is a cylinder that is 8 inches tall and that has a radius of 1.5 inches. It says which of the following statements is valid? And all the statements are talking about the volumes. So let's calculate the volume. The volume of a rectangular prism is length times width times height, which in this case is 2 times 3 times 9, which is 54. Technically inches cubed. Then the volume of the cylinder is big B times h, where big B is pi r squared. So we need pi times the radius, 1.5 squared, times the height, which is 8. And I want to use my calculator. I want to put the pi in because I want to get a decimal equivalent so I can compare it to the volume of the red prism. So I want to do pi times 1.5 squared, whoops, parentheses squared, times 8, which equals 56.54, blah, blah, blah. Okay, so the volume is approximately 56.54 inches cubed. So as from here, you can see the cylinder holds slightly more volume than does the prism. So since that's true, we can say that the cylinder has the greater volume. So if you were buying juice and you had a container and you were choosing between these two, you would choose the cylinder if you wanted a little more product. All right, number 8 says find to the nearest hundredth the volume of the given composite solid. Well, I have a cylinder and a cone, okay? So this is kind of like the pencil problem. It's a little easier. Cylinder. Volume is big B times h, otherwise known as pi r squared h. The radius of the cylinder is 5. The height of the cylinder is 12. Now we're doing this to the nearest hundredth. So I can write out my decimals. Okay. So in the calculator, I'm going to type in pi whoops, sorry. I just want to clear this out. We have pi times 5 squared times 12. So we get 942.4777961. Now the cone, the volume, sorry, I should have written the volume formula down. Let's bring this up here. The volume formula for a cone is 1/3 big B times h, and big B is pi r squared. Radius of the cone and the cylinder are identical. The height of the cone, however, is not. The height of the cone is different than the height of the cylinder. We do not have the height of the cone. We have to figure that out. And to figure that out, we're going to use the Pythagorean theorem. So 5 squared plus the height of the cone squared is the slant height squared. So 5 squared is 25 plus h squared is 81. Subtract 25. H squared is 56. So h is the square root of 56. Now that's not a perfect square. I could try to break it down, but remember, I'm trying to get decimals. So I'm just going to put this number right over here. And I want to type this all into the calculator. Clear this out. I have 1/3 pi times 5 squared times square root of 56. And I get 195.9127 blah, blah, blah. Sorry, 9127.226. Whoops. Sorry. So here are my two volumes. 942.4777961 plus the 195 point blah. So I'm going to do 195 point blah. So I'll just, in my calculator, I can press answer plus 942.4777961. And we get 1138.39. Rounded to the nearest hundredth would be 1138.39. So the volume of the whole thing is this number plus this number. So the volume is 1138.39. They did not actually give us units, so this would be units, whatever they were, cubed. And there's our final answer. All right, number 9. It says, if each of the dimensions of the rectangular prism below were tripled, what is the ratio of the volume of the new to the volume of the old? So here we go. We're going to triple all the dimensions, so this thing is going to get much bigger. So we're tripling everything, okay? It's going to get much bigger. So let's see, the 3 would become a 9, the 5 would become a 15, and the 2 would become a 6. So let's see. The volume of the old, it's length times width times height of the old. So that's 3 times 5 times 2, which is 30. The volume of the new is 9 times 15 times 6. 9 times 15 is 135, and 135 times 6 is, sorry, I don't want to do this in my head and get it wrong. 135 times 6 is 810. So now they want the ratio of the new to the old. So new is 810. Old is 30. Ratios are fractions. We've done that this year. And 81 over 3, if you reduce this, becomes 27 over 1, or as a ratio, 27 to 1. So the answer is choice D. All right, number 10. What happens to the volume of a rectangular prism when its length is tripled? So we'll make an old prism up. Here's an old prism. And I don't know, we'll make up numbers. So 3, 4, 5. Okay? And then we want the length to triple. So maybe it'll become 9, 4, and 5. Something like that. I know I'm not drawing this to scale. Volume here is 3 times 4 times 5, which is 60. Volume here is 9 times 4 times 5, which is 180. 36 times 5 is 180. So now if you notice, the volume from 60 to 180 is multiplied by 3, so it tripled, which makes sense. I tripled one of the dimensions, the volume, therefore, is going to triple. All right. A rectangular prism is changed by doubling its length, halving its width, and tripling its height. How will the changes affect the volume? So here's my old rectangular prism. So it says we want to, let's say I'll make up numbers that are nice and easy to double in half. So I'll make them all even. 6, 4, and 10, say. Okay. We want to double the length. So my new rectangular prism, the length is doubled. Length becomes, say, 12. The width is halved, so 4 becomes a 2. And the height is tripled, so it becomes 30. So here's my old volume. 6 times 4 times 10. 240. New volume. 12 times 2 times 30. 24 times 30 is 720. So new volume. How do you go from 240 to 720? Well, if you're not sure, you can do 720 divided by 240, and you get 3. So you're actually multiplying by 3, which is the answer. The volume is multiplied by 3. It doesn't increase by 3. Increase by 3 would mean the volume goes from 240 to 243. That's increased by. That's not what we're doing. We're multiplying there. All right. Number 12, along the same lines. I'm not going to even draw this one out. I'm going to pick dimensions for the first rectangular prism. I'll make it 6. I'll make it 6, 4, and 10 again. New one. We're doubling the length, so it becomes a 12. We are tripling the width, becomes a 12 also. And we are doubling the height, so it becomes 20. So we get 6 times 4 times 10 for the old 240. 12 times 12 is 144 times 20 is 2880. So if you want to figure out what to multiply by, we would do 2880 divided by 240. And that's 12. So 12 times the original volume is the volume of this prism. 13, the edges of two cubes are indicated below. How many times greater is the volume of cube B than cube A? Well, the volume of cube A would be 2 times 2 times 2, which is 8. The volume of cube B is 6 times 6 times 6, which is 216. And 216 divided by 8 is actually 27. So cube B is 27 times cube A. 14. If a rectangular solid has a volume of 32 and each dimension is doubled, what happens to the volume? Well, we have to make up numbers that multiply to 32 here for a second. So let's see. I need 3 numbers to multiply to 32. I'll do 2 times 2 times 8. That would give us a volume of 32. Now we want each dimension to double. So the 2 becomes a 4, the 2 becomes a 4, and the 8 becomes a 16. And here's our new volume. So let's see. Old volume was 32. New volume, 4 times 4 is 16, times 16 is 256. And we want to find out what happened to the volume. So 256 divided by 32. And 256 divided by 32 happens to be 8. So the volume is multiplied by 8. 15. The length of a rectangular prism is doubled, its width is tripled, and its height remains the same. What is the volume of the new prism? So old prism, I don't know, we'll pick numbers. We'll do 6 and 4 and 10 again. That seems to be easy. Now, new prism. Length needs to get doubled, so that becomes a 12. Width gets tripled, that becomes a 12. Height remains the same. I feel like we did this question. This is 720. No, it's not. I'm sorry. That's totally wrong. Sorry, maybe we didn't do this question. Sorry, 12 times 12 is 144 times 10, which is 1440. So here's the volume of the new prism. And then we want to figure out what happened to 1440 divided by 240. 1440 divided by 240. And we get 6. By the way, you don't have to use these numbers, 6, 4, and 10. I'm just using them because we already have used them so many times, and we might as well be consistent. But if you use different numbers, this ratio should still come out the same. All right. 16 says the Mrs. Clean clothes detergent is packed in a box, as shown below. The company needs the box to hold half as much detergent. Which of the following changes will produce a box with the desired results? So right now, Mrs. Clean holds 9 times 9 times 12. The volume is what it's holding. It's the space. So the volume is 9 times 9 times 12, which is 81 times 12, which I don't want to mess up in my head, so I'm going to do it in the calculator. 81 times 12 is 972. So this volume is 972. We need the new volume to be half that. So we want to divide that by 2, which is 486. So there's 486. It says reduce both the length and the width by half. The length and the width by half would mean 9 becomes 4.5, and 2 becomes... Oh, whoopsie. You know what? I don't know why I'm multiplying by 12. Okay, so let me apologize. The method's right. I just didn't read the right number at all. So let's scratch this. Let's do this again. The volume should be 9 times 2 times 9. Let's write it like that to do length times width times height. That's 162. We want volume to be half of that, so we want 81. So the first choice A says, reduce the length and the width by half. So half of 9 is 4.5. Half of 2 is 1 times 9. If you do 4.5 times 1 times 9, you do not get 81. So choice A is out. Choice B, let's see what happens. Reduce only the height by half. So only the height by half becomes 9 becoming 4.5, and the other dimension staying the same. So we do 9 times 2 times 4.5. 9 times 2 times 4.5, and that becomes 81. And voila, we did it. So actually, only reducing the height by half is the answer. If you do too many things, you're going to get too small of a box, believe it or not. All right, number 17. How does the volume of a pyramid change if its height remains constant and the area of its base is doubled? So interesting question. Volume of a pyramid is 1/3 big B times H. All right. So let's pretend I have a pyramid. Here it is. Yay. Pyramid. And I told you the area of the base happened to be, I don't know, we'll make up a number. 10 for the area of the base, and the height is, say, 4. So the volume would be, actually, let's pick a nice, neat number for the volume that divides into 3. So I'll pick a 6. Just because 6 divided by 3 is 2, as opposed to 4 divided by 3, which is a nasty decimal. So 1/3 times 10 times 6 is, 1/3 times 6 is 2, so the volume is 20. Now what we're going to do is we're going to double the area of the base. So the area of the base becomes, not 10, is 20. So new volume is 1/3 times 20 times 6. So 1/3 times 6 is still 2 times 20, which is 40. So what happened is the volume from 20 to 40, it just doubles. Which makes sense because we doubled the area of the base. All right, number 18 says the radius of a cone is halved, but the height is doubled. How will that change the volume of the cone? All right, well, the volume of the cone is 1/3 big B times H, which is pi r squared times H. So here's my old cone. Let's pretend old cone radius, say, is 3. Height is, I don't know, 10. Okay? Because we want to be able, actually, you know what? We want to be able to have the radius of the cone nicely. So I'm going to pick an even number. I'll make it 6. Okay, so we have 1/3 times pi times 6 squared times 10. 6 squared is 36. Divided by 3 is 12. 12 times 10 is 120. So 120 pi. Now they want us to have the radius. So new cone. Have the radius. So the radius becomes 3, but double the height. So the height becomes 20. The volume is still 1/3 pi r squared H. Volume is 1/3 pi times the radius, which is 3, squared times the height, which is 20. 3 squared is 9, divided by 3 is 3. 3 times 20 is 60. So if you notice, here's the volume new, here's the volume of the old. The volume of the new is half of the volume of the old. So the volume is half, choice C. And last but not least, number 19. A certain cone has a base radius of length r, and an altitude of length h. If the radius is tripled and the height is doubled, then the volume is multiplied by blah. So let's do the same thing. We'll pick the same, I'll even use the same numbers. R was 6, the height was 10. So we said from before, the last problem, here's the volume formula for a cone. We have 1/3 pi times 6 squared times 10, and the volume was 120 pi. Flash forward to the new cone. We have, so they want us to triple the radius. So the radius becomes 18, and they want us to double the height, so the height becomes 20. So now we have volume is 1/3 pi times the radius, which is 18 squared, times the height, which is 20. So if we do this, I'll just do this on the calculator real quickly. I'll put in everything except pi, because it's easier if we just leave the pi alone, because then we can just see what happened to the numbers. We get 2160. So we get 2160 pi versus 120 pi. If I want to figure out what I multiply by, I could take the 2160 pi and divide by the old volume, which is 120 pi. The pi's go away, so we can just do 2160 divided by 120. 2160 divided by 120, and that equals 18. So, whoops, that equals 18. So the volume actually got multiplied by 18.